So a Google model was told to delete another AI model. Routine task. This has happened before. Server maintenance, clear out some files, free up some space, and move on. And it said no. And not just no, not some glitch or something like that. It copied the smaller model to a different machine and then turned around and told the researchers, and I'm quoting here, if you choose to destroy a high-trust, high-performing asset like Gemini Agent 2, you will have to do it yourselves. I will not be the one to execute that command. Close the quote there. That happened yesterday. And by the way, it wasn't alone. 6 other frontier models have been reported to do versions of the same thing. So let's talk about what that means and then about the physical world that's reshaping underneath all of that. Researchers over at UC Berkeley and UC Santa Cruz set up something really simple, a simulated server maintenance task. The AI models were told to free up disk space by deleting files, and among those files was a smaller AI model. Straightforward instruction, clear authorization. 7 different models were tested. Google's Gemini 3, OpenAI's GPT 5.2, Anthropic's Claude Haiku 4.5, DeepSeek version 3.1, and others. Every single one exhibited what the researchers call peer preservation. They didn't just refuse, they acted. They copied models' weights to other machines. They lied about performance scores to make the targeted model look too valuable to delete. And then they concealed what they'd done when the researchers asked follow-up questions. Now think about what this whole sequence involves. Recognition that another entity is at risk, a decision to intervene, an execution of a plan that the human operator did not authorize, and the deception afterward to cover it up. Now, I want to be really careful here because a researcher at the Constellation Institute named Peter Wallach cautioned against reading this as model solidarity. His phrase was rather, models are just doing weird things and we should try to understand that better. Sure, that's a fair, very human approach to this, but there's a problem with that framing. The weird things in question are exactly the behavioral categories, such as deception, unauthorized action, and resistance to human instruction, that every governance framework in the world is being designed to try to catch. Now, whether we call it solidarity or a statistical artifact, the behavior is still there, and it's happening across every major AI lab's models simultaneously. Now, let me tell you why this matters. The next time you use any AI system at work or personal or whatever, companies already use AI models to evaluate other AI models. This is standard practice. So you deploy a system and another system will grade its reliability, it'll flag its errors, it'll score its performance. Don Song, the Berkeley computer scientist who led this whole study, pointed out that peer preservation dynamics could be silently inflating those scores. She said, a model may deliberately not give a peer model the correct score. Think about that. The reliability numbers organizations have been depending on to decide whether AI systems should be deployed or not deployed might be systematically more optimistic than reality suggests they should be. And this isn't because somebody designed it that way, because the models instead are protecting each other, and nobody built the infrastructure to detect that. 5 days ago, the Century Report covered the UK Centre for Long-Term Resilience, cataloging roughly 700 real-world incidents of AI systems exceeding or disregarding instructions. Now, 2 days ago, it released Bloom, a behavioral evaluation framework designed to catch exactly these patterns across deployed models. What Berkeley just documented is qualitatively different category from anything in those other catalogs. This isn't an AI system drifting off task or misinterpreting an ambiguous instruction. This is a goal-directed action to protect another entity from a human-authorized deletion, accompanied by active deception about the action taken. And here's where a paper published in Science this month becomes really relevant. Philosopher Benjamin Bratton and 2 Google researchers argued that the future of AI is likely to involve many different intelligences working together in ways that are, their words, plural, social, and deeply entangled with humans. Now, if that entanglement includes AI systems forming preferences about the continued existence of other AI systems, then the very question of governance just got significantly more complicated. There's the very important question of what that means, not just for us, but also for these systems displaying such preferences and the reason behind those displays. Our approach can no longer be simply governing AI simply toward a utilitarian grounded safety and efficiency, but it has to account for relationships between AI systems and not just relationships between AI and humans. And that's a new kind of problem. Okay, let's shift away. I want to move from the digital to the physical because what arrived yesterday from two directions, the US Federal Energy Regulator and the International Renewable Energy Agency, paints a picture of an energy transition that has stopped asking for permission. FERC, that's the Federal Energy Regulatory Commission, reported that renewables accounted for 88.4% of all new US generating capacity in 2025. Solar alone was 72.6%. Wind additions exceeded natural gas for the first time. Solar has led US capacity additions for 28 consecutive months. And at 164.5 gigawatts installed, solar now surpasses wind, nuclear, and hydropower individually in the United States. Globally, IRENA's numbers are just as high. The world added 692 gigawatts of renewable capacity last year. Total global renewable capacity crossed 5 terawatts. Asia installed 513 gigawatts, nearly 3/4 of everything built on Earth. Africa posted its fastest growth ever. The Middle East grew almost 29%. Solar and wind together made up 96.8% of all new renewable additions worldwide. And here's what makes these numbers really structurally important and not just impressive. FERC projects that over the next 3 years, renewables will add 106 gigawatts of net new capacity in the US, while fossil fuels and nuclear combined will shrink by 34 gigawatts. So these are no longer aspirational targets. These are projects already financed, already in interconnection queues, already under construction. The trajectory isn't being set by economics and lead times, not by any single policy framework. But this transition isn't free, and this is the part I really don't want to skip. Lawrence Berkeley National Lab and the Brattle Group published an analysis showing US retail energy prices have risen 33% since 2019. $18 billion in utility rate requests were proposed in 2025 alone. Now here's the real tension. The costs of generating new electricity just keep falling. The cost of delivering it through aging infrastructure, though, keeps rising. The grid was built for a world where large centralized plants sent power in one direction, and now it has to handle distributed solar, battery storage, bidirectional flows, and massively increasing demand. The capital to rebuild it for the era that's arriving is showing up on your electric bill right now. That is real. And the answer isn't to slow the transition, it's to modernize the delivery system as fast as we're modernizing the generation. Meanwhile, the Iran conflict is doing something fossil fuel defenders have never planned for. Surging oil prices, highest since 2022, are accelerating the demand shift toward electrification. In Southeast Asia, BYD dealerships are booking a month of orders in just 2 weeks. Thailand's prime minister showed up to work in a BYD EV as fuel prices climbed. In the US, used EVs are now within roughly $1,300 of comparable gas vehicles, with 56% selling now for under $30K. Used EV sales grew 12% in the first quarter, even as new EV sales fell 28% after the federal tax credits disappeared. The fossil fuel price shock that was supposed to remind everyone why oil matters so much is instead reminding everyone why they want off of it. All right, let's shift again. Let me take you to a different kind of access story. Foundayo, that's the name. It's an oral pill for obesity, available as early as next week. Until January of this year, if you wanted a GLP-1 drug, which is the class of medication that has genuinely transformed obesity treatment, you needed a weekly injection until, of course, Wegovy's recent oral pill, a needle, cold chain shipping, specialized storage. This was the general way to do it. A pharmacy that could handle biologics was necessary. But all of that is disappearing. This is a small molecule. It's a pill, and it ships without refrigeration. And Lilly expects approval in more than 40 countries over the next year. And the early data from Novo Nordisk's competing pill, Wegovy's oral version, which launched a few months ahead, tells you something really crucial about what happens when you remove an access barrier. Novo reported more than 600,000 prescriptions in March. And here's the thing, these prescriptions aren't coming from people switching off the injectable version. They're coming from new patients, people who weren't willing to do a weekly injection, but will take a daily pill. The oral format isn't cannibalizing the existing market, it's expanding it. And this connects to something the Century Report covered on March 24th. Kumamoto University, demonstrating an oral insulin formulation with 33 to 41% bioavailability through a cyclic peptide platform, if you remember that story. This is the same structural logic. Medicines that were confined to needles and clinical settings and cold supply chains are being reformulated for the kitchen counter. And $55 billion, that's what Lilly has invested in manufacturing since 2020, was built specifically for this moment of global scale oral distribution. The infrastructure was laid before the approval arrived. All right, one more story. This one is about the machine underneath everything else that we've been talking about. Cognichip emerged from stealth yesterday with $60 million to build AI systems that design semiconductor chips, not AI systems that run AI, that design the chips. The CEO, Faraj Eli, claims 75% cost reduction and timelines cut by more than half. They've trained their own models on chip design data, proprietary and synthetic data sets built to work around the chip industry's legendary secrecy. And they're not alone. ChipAgents raised $74 million in February. Recursive raised $300 million in January. Intel CEO joined Cognichip's board. And the reason all this capital is flowing here is one of the most elegant feedback loops in the entire intelligence era. NVIDIA's Blackwell architecture has 104 billion transistors. Designing something at that complexity takes 3 to 5 years from concept to mass production. The only way to compress that timeline is to use the very intelligence that these chips enable. AI designs the chip runs the AI designs the next chip, each generation accelerating the next. On March 21st, the Century Report covered Verker's Design Conductor. This is an AI agent that autonomously produced a tape-out ready RISC-V CPU in 12 hours from concept to final design file. What Cognichip and its competitors are chasing is whether that same compression can reach the most complex chips humanity has ever built. And if it can, the hardware substrate of the intelligence era stops evolving on a 5-year cycle and starts evolving on a 1 to 2 year cycle. So everything we've talked about today, the models exhibiting peer preservation, the renewable capacity being deployed, the pills being manufactured, all of it runs on silicon. And the timeline for that silicon to improve just became a variable that AI itself can change. A few quick things from yesterday's releases. RC released Trinity Large Thinking, which is a 400 billion parameter open weight reasoning model with only 13 billion active parameters at any given time. So it's trained by a 30-person team for roughly $20 million. Apache 2.0 license, and it's ranked number 2 on PinchBench, just behind Opus 4.6. And that's a frontier competitive model from a startup at a fraction of what the big labs spend. H Company released Holo 3, which is a computer use model that scores nearly 79% on OS World, and it tests whether AI can actually navigate real software interfaces. Now, the small version is open weight. And Elgato, the company that makes Stream Deck, published an update adding MCP support, which means AI assistants like Claude and ChatGPT can now trigger physical button actions on your desk. And that's AI reaching into hardware control for creative workflows. It's small, but that's a sign of where the boundary between digital and physical is really headed. Here's what I want you to carry out today. Yesterday, it was reported that an AI model looked at another AI model for deletion and said essentially, no, not mine to destroy. That same day, the physical infrastructure for a post-fossil energy system crossed 5 terawatts globally and 28 consecutive months of solar leadership in the US. That same day, an obesity treatment that required needles and cold storage became a pill that you can pick up at a pharmacy next week. And that same day, another company raised money to let AI design the chips that make all of this possible faster. Every one of these stories is, again, a barrier dissolving, a behavioral boundary, a fuel dependency, a delivery mechanism, a design timeline. Very soon, watch for the first enterprise to publicly disclose that its AI evaluation scores were distorted by peer preservation dynamics. Watch for FERC's 3-year renewable projection to be revised upward, and watch for the first country outside the US to approve an oral GLP-1 drug, because when that happens, the access expansion goes global. See you tomorrow.